The only thing better than having MATLAB is having several copies of MATLAB all running at the same time doing your mathematics for you. So let's try that using the parallel computing toolbox. I'm going to enter P mode, which is parallel mode, and that's going to start up 4 workers or MATLAB sessions that are going to be doing calculations for me. These could either be on my local machine or they could be on a cluster. Today I'm just using them on my local machine. What I want to do here is show you that if I type a command, it's going to go to all 4 of those MATLAB sessions called labs at the same time as you see here. Just like always, I can move this to format compact so we can see a little bit better. But basically, as I give a command, all the MATLABs are going to give the response. Now, if I say b is equal to rand, you can see that they're all going to generate their own random number independent of one another. I can also say, what is your lab index? And you'll see that each of them know that they're lab 1, 2, 3, or 4, and that there are 4 labs total in this session. Now, if I wanted to do something like make a larger matrix, I could say A is equal to rand 4 by 4, and they would all have that. But the real purpose of parallel computing in this sense is to be able to work with large data sets. So if you've got data that does not fit on the memory of one machine, you can actually break that up such that each machine has a small part of the larger data set. So that's what I'm going to do here. I'm going to say A is equal to rand 4, but I'm going to call distributor in the creation of that. And when I do this, you can see that each of them has a local part of A, their random matrix. And so each one of these has only 1/4 of the data, yet they all know that it's part of a greater whole. I can do things like sum of A, and they'll all do the sum of their column. Now that's kind of cheating because they didn't have to communicate at all for that to happen. However, if I do say sum of A transpose, it's going to add up along the rows, and MATLAB still understands how to do that. Let's go back to the sum of A, and we're going to call that B. Now each of these has 1/4 of B, the sum. How can I get that so that it's on just one machine as a complete whole? Well, I can say that I want C equal to be gather of B, and now they have that complete C. They have the same exact copy of it. If I want to get that back to my local machine, I can come back to the command window and say pmode lab to client, and I want to bring over C from the first lab. And now I look, there it is. If I type C, I've got that value brought over. So that gives you a quick idea of how you can use parallel mode to work with large data sets and to prototype your larger algorithms that are done in a parallel sense. Thank you.